everybody. Today we're going to discuss about gravity. What is this force that spreads across the universe and how come we have it in our world? Well, if we know that before the universe, space was flat and time was zero in this manner, the empty set, something must have happened that we have space curved the way it is today and time is 1 second every second. Now, if before the universe is created, what we have is linear radiation, the question is, what do we need to do in such a way we have curved radiation we have it today? Something must have happened. And I have presented in my previous video the fact that we have an explosion taking place here, another one here and here and here, and everywhere inside the universe being a sphere, in such a way, if I discharge an energy that powerful in order to create mass, since the fuel of mass is light, inside these 8 spheres, these 8 explosions, I create one sphere of mass. That minimum sphere that we have in this universe is this one. All these spheres were created in the initial second of the universe. An explosion of this magnitude or higher is needed. And that happened in the initial moment of the creation of the universe. This is how mass gets created. Now, the question is, if all radiation overlaps with all the other radiation, why this doesn't happen in the same manner with mass? As another question could be, if this mass is made of radiation, why does this mass doesn't explode back in one big nuclear explosion 1 second after the universe is created? So after 2 seconds we have the same situation as before. Something prevents this mass from exploding back. What prevents that? I have stated this previous. It seems that in this universe we have 2 zones. This zone and the other zone, or this side and the other side. On this side there can be only mass, and on the other side there can be only radiation. What does this mean exactly? So, what we have here is a minimum sphere, the initial sphere made of mass, which was created in the first fraction of the universe. This is smaller than the electron or the proton or the neutron. It's that minimum sphere of mass. Now, if this is made of light, it means that somehow we have had the power to curve light in this sphere. And inside there is light, radiation if you want, not just call it light, let's say radiation. And radiation is curved by this discharge, but it tries to stay as a line. Other way of saying it, this radiation tries to explode back. So something is needed to prevent it. It's not enough to create mass, you just need to hold it forever and ever. So there is a way this can be done. The initial explosion of the Big Bang is still happening today, and we see it everywhere where we look. Somehow the initial energy was that powerful, it created, let's call it pressure. Think about it that we are inside an aquarium. And if this is a universe, and we are inside, if I bring an explosion takes place everywhere, it increases pressure. If this pressure is high enough, all the spheres of mass, they do not explode back. What presses on this surface is the initial explosion of the Big Bang, not only on this sphere of mass, but all the spheres of mass, and this prevents them from exploding back. What does this mean? We have this sphere of mass surrounded by a reverse sphere. This reverse sphere presses on the surface of this sphere, preventing it from explosion. If this has the mass m, this force is this one over here. And this force is distributed and presses on every single sphere of mass from the entire universe, preventing it from exploding. In such a way, this sphere remains stable. Now, this force, you can see it everywhere. Everywhere into the universe where we have mass, we have gravity. And where we have gravity, we have mass. We cannot separate them. The question is, which one was first? It's the mass or the gravity? If you go back to the beginning, we see that they come together. Every sphere comes with a reverse sphere. And each time we have mass, we have gravity. It's not the gravity who generates mass, it's not the mass who generates gravity. They come together, and they were all formed in the initial moment of the universe, like this. I have presented this in my previous video. Now, if this happens to one sphere, what happens if I put more spheres together? When two spheres encounter, why they do not overlap? All the light in this universe, all the beams of radiation overlap with all the other beams of radiation. But mass can never overlap with the other mass. Why does this happen? What prevents this from happening? Well, what prevents it is this surface. So, let's say we have in our universe a sphere. Let's call it hydrogen, if you want, a subsphere of an electron, if you want. And this sphere of mass is surrounded by this reverse sphere. What happens when two spheres like this one encounter each other? If I apply the principle of distribution of forces from Newton, somehow these two forces right here in this point, they cancel each other. But this works only on this side of the universe. On the other side, seems to have the tendency to overlap, to pass over it between them. This reverse sphere are somehow radiation, and radiation overlaps with the other radiation, which means if I want to compose these forces, I have to do it in a mirrored manner. In this case, it means like this. This force over here, let's call it 1, is equal to this force over here. And this is 2. I have to take this one from here, from this sphere, and put it here. And I will put it here as 2. On the other side, it's the same. It's 2 here. In this portion here, and in this zone here, situation doesn't change much. So here it's pretty much the same. But where is interesting is here and here. This zone has a higher value, and this one also. Now this is important. We don't see that much of a change in case of two spheres. But let's go crazy. Let's say we have 3 spheres encounter or more. 4 or 5 atoms of hydrogen or more. We can go farther away with our judgment. And since we have in this universe a lot of mass, let's say we have something like an asteroid or a planet. How would gravity look like? Well, those forces distribute in real time in all directions. So each time when I bring one more sphere here, the force is higher and it distributes itself in all directions. If there are enough, if there are many, eventually I have gravity by a sphere everywhere in all directions. Now this is something that we can see everywhere on our planet, on our stars, because this force is the sum of all these little forces. They combine each other and the gravity stays constant if this planet stays constant. If density is somehow constant, these things do not move much. In reality it's a little different, but we don't feel any kind of differences in gravity because this magma, or you want to call it, inside our planet doesn't move in real time that much. So if there are slight differences by rearrangement of density from these spheres, we are not affected. But the mechanism is this one. And because of this mechanism, there is no need of Higgs boson. There is no need of tiny little sphere somehow behaving in a strange manner that creates an attraction force with other spheres. No, it's not the sphere of mass which creates gravity. Gravity is outside of the sphere. It's a reverse sphere pressing on every single sphere of mass, preventing it from exploding, and that force is what we are measuring and we say is gravity. If I would ask you, how many reverse spheres are in the universe? You should tell me as many as spheres. And it is like this. Right now in this universe, we have a number of spheres of mass and exactly the same number of reverse spheres. This is what prevents the spheres from exploding, that constant pressure of the initial Big Bang. Now, to explain this better, once again, we have to see that we have two zones in this universe which were separated in the initial moment of the Big Bang. This side is where only we can put mass, and the other side, between these spheres, is where we put radiation. Radiation travels between mass. That is what we see at light that has that ondulatory behavior. So if I have a star here shooting light, light will travel between these spheres. But these spheres are not standing still, because the initial blast also gives an initial kick to the universe. And in this movie, Empty Space is Not Empty, which is not mine, you will see it on the internet, you will see this movement. And you will see it here, that we can put mass only on this side of the universe. And we can put radiation only on the other side. But because of this diameter is very small, we have the feeling that mass and radiation are everywhere. Right now in this room, we have mass and we can have radiation, because this diameter is very small. Why is this important? If this diameter would be higher, we would somehow lose resolution in this universe. And when I would move, I would somehow feel it. But I don't feel this the other side, because this diameter is very, very small. This increased resolution is very important for the behavior of the universe. So, in conclusion, you have to understand that gravity was created initially of the Big Bang, and we can still see it today as a result of this explosion. This constant pressure presses on every single sphere of mass in such a way it stays constant. There is another element which is important in this case. In order to have movement in this universe, it's not enough just to create a universe in the manner I have explained this already. Because this movement happens all the time, these spheres of mass also move. Otherwise, things will stand still after a while, after a few seconds, not millions of years, the universe will stop. But you don't see that. What triggers the main power of the universe itself is not gravity. The main power that pushes everything around without everything stopping is this force. It's a Big Bang which is still happening today, and it will happen until the end of time. This is a force that pushes things around. The other forces are just secondary forces. And when two things encounter, you see gravity. You can talk about electromagnetic force, the weak force, the strong force. Okay, those are details. But without this, if things will stand still, spheres will never encounter each other. They will just stop. This movement is fundamental. The initial kick that every sphere of mass has received initially at the creation of the universe had to be somehow maintained. And it is maintained every single second. And it's happening right now. That is why if I would ask you, I'm giving you a sphere, make it stop. Make it stop. Even if I hold it like this, it will not be stopped, because the subcomponents, the electrons, the protons, the neutrons will just spin within themselves. Also, by looking at it, it doesn't move. The subcomponents move. The question is why? Why would they move? What triggers them? An initial kick, previous collisions? No, it's this movement. It's the initial Big Bang. What does this mean? If I have a sphere which is made of mass, and I put it here, this is a sphere, it can stay only here. And in space moving, it needs to vibrate within itself in order to avoid staying here. With radiation it's the same. So if I have radiation, also radiation is a line, as I'm traveling to a curved universe, this movement curves me. Although I'm a line, I travel to a line and I want to travel as a line, because originally light it is a line, like I have said this before the universe was created, space was flat and light was a line, a pure line. Now light has this curved behavior, although it travels in a line. This movement of the space of subatomic level curves that light trajectory. In such a way, light always stays between spheres of space. There is an analogy I can do it so you can understand this better. If this is Earth and I put water over here, let's say there is a level here, and I put water, water is going to infiltrate like this. Forgetting about gravity, water is going to infiltrate, let's use red better, in all directions. Like this, and like this. Now, someone would say, okay, but that happens because I have Earth here. If I take the Earth out, water will just flow directly. It looks like this for us, but at subatomic level, if there is nothing here, water will somehow travel like this. And we see that in the universe. When there is nothing, light doesn't lose its ondulatory behavior. It still travels at an undulate manner, although there is nothing there. And this proves to me this behavior is what prevents light from staying here. Only mass can be placed here, and only a reverse sphere can be placed between the spheres of mass. This is how the universe works. And every single sphere of mass needs to have a reverse sphere around it, pressing it on its surface in such a way we have contact. If there would be no contact between two spheres and they would overlap, there would be no time. If there would be no time, we would be outside the universe. We would be like before the universe. We need interaction in order to have time. That surface between this side and the other side is needed. Without that, there will be no interaction. Without interaction, there will be no time. And all radiation will just overlap with the other radiation without ever seeing anything new. If nothing would never happen, we would never have time. But here we have the time because there is interaction between one sphere of mass and the other one. This force of the reverse sphere prevents this from overlapping. And this reverse sphere pressing on mass is what is gravity all about. I think I have explained this very clear. If you think that things are not like this, please write to me and I will answer back. Thank you for watching.